So number 16 involves a Norman window, which has a semicircle at the top and a rectangle at the bottom. So it's kind of like the track problem we talked about yesterday, but instead of two semicircles, you just have one semicircle. So if we take a look at this one, I'm going to do a little drawing. So something like that. And it's going to benefit you if you thoughtfully pick your variable. So in last class, we chose the variable to be kind of the diameter for this. And that's a good choice, but it ended up being, I think, a lot more work. And really, the only way you determine what will be your variable is by practicing, and sometimes you have to start over. But to avoid that, I'm going to call the variable in question r, so that is the radius of the circle. It is not wrong to do it the other way, it's just a little uglier. So when we consider that particular length r, the distance across the bottom will be twice the radius, because that's essentially the diameter of the circle. And even if you didn't do this problem before, you want to write this down. Like, you're going to want to have a record of it. I don't care if you did it ahead of time or didn't. So now, if we consider the circumference, so that's the length across the top, the curved length across the top, what would that distance be across the top of that? So pi r. So when you consider circumference of a whole circle is 2 pi r, the circumference of a semicircle is, Soham said, would be pi r. So circumference of a semicircle would be pi r because it is half that. So the top is pi r, and we know the bottom is 2r. What we have to consider then is what is the length, what are the lengths of the two vertical sides? So
would be 20 minus pi r minus 2r over 2.
Good. So essentially we have 20 feet to go around the entire window. We have used up pi r at the top and 2r at the bottom. So if we want to write that as a singular amount, we could, but you know, it's not going to help us too much because not all of these are divisible by 2. But again, if we wanted to, we could write it as 10 minus pi over 2r minus r, if we want to simplify it. Now, what we need to do is maximize the window, because we want to have the most light shining through as possible. So that's all about maximizing the area. So what we need to do is write an area equation. So we know the area is going to be the area of the semicircle. So the area of the semicircle is half the area of a circle, so it is pi r squared over 2. Pi r squared over 2 is just, you know, half the circle. And then the rectangle is going to be the length times the width. So the length, or the width is 2r, the length is 10 minus pi over 2r minus r. And that is that piece of it right there. So we have the area of the semicircle plus the area of the rectangle is the total area, and that's how much light gets let in, given we want the distance around the whole thing to be 20. Any questions so far? Okay, so now we want to maximize this area. So we do need to get it into some usable form where we can spot the vertex. So it's going to be pi r squared over 2 plus 20r minus pi r squared minus 2r squared. questions on that distribution? All right, so now we have to combine our like terms. So our like terms are going to be everything with an r squared. And unfortunately, even though those are like terms, they all have r squared after them, it is tough to combine numbers with pi with numbers that don't have a pi. So we have to be extra kind of diligent on this. So if you add together pi halves and negative pi, that is like adding together 1/2 and negative 1. So if you consider it 1/2 pi and negative 1 pi, what is 1/2 plus negative 1? Negative 1/2. So that's negative 1/2 pi r squared minus 2r squared, bringing together all the r squareds together. So again, 1/2 pi minus 1 pi is negative 1/2 pi. Those combine to that, and then I just brought them at negative 2r squared. So in order, and then plus 20r. In order to make a cohesive a value, again, the a value is the coefficient of the r squared, what we're going to have to do is factor out everything that is a coefficient of an r squared, and that'll give us an a value. So if I factor out the r squared from these two terms, I get negative 1/2 pi minus 2 times r squared plus 20r is a. So this is a, and this is b. So when we do negative b over 2a to find the radius maximum, the radius that will maximize the area, that is what we will do. Now, if all of this makes you uncomfortable, all these pi's, all these crazy coefficients, you can use a calculator and calculate the value of negative 1/2 times pi minus 2. And just use that number. I would probably do at least 4 significant digits, so your final answer isn't super weird. But again, if you hate all of that, just make it a decimal. All right, raise your hand if you want me to make it a decimal. Okay, so go ahead and calculate negative 1/2 pi plus minus 2. Make sure, remember, you'll have a scientific calculator for this, but right here.
How do you pi? I do carrot. No.
Oh, you have it? Okay, Kishore, what did you get for that a value then?
Negative 3.5707. Well, 5708.
Okay, so there we go. We get negative 2.5708 r squared plus 20r. Did anyone have difficulty getting that particular value, or maybe have a different value they think is right? Okay, so now going up here, I know this is a negatively oriented parabola, so I know the maximum will occur at x equals, or in this case r equals, negative b over 2a. So negative b is negative 20 over 2a, which is 2 times negative 3.5708. So what r will maximize the area inside? Go ahead, Rhea. let's do some more dishes, or is that it?
2 point, I can't do 6 things, 0, 0. Is that the same thing? That's what it says.
Yeah, we'll go with 2.8. All right, so R equals 2.8 feet. So it says, what dimensions will admit the most light? Questions on this amount? Okay, so the dimensions are, and dimensions for this is a little weird. We know the radius of the semicircle is 2.8 feet, so we do know that. What we'd have to do then is plug in 2.8, so there's our answer for our radius, and we want to probably plug that amount in to this quantity to find out how long we make the Norman window, because that is also in question, is how far down the rectangle would go. So for that, sorry, I need another arrow here. We would do 10 minus pi halves times 2.8 minus 2.8. Plugging in R where we see R. And that will give us, because you could have a circle on top, but like any number of rectangles on the bottom. Can someone do this calculation for me?
Not 2.8, but.
Yeah.
All right, so 2.8 feet. So again, going to our nice square. So the rectangle, and giving the dimensions, the radius is pretty clear, and then I'd probably just label this side of the rectangle as also 2.8. So here is 2.8 feet. All right, Nadia?
I did the same calculation for the radius, but I got a much bigger one.
So you're gonna wanna put this whole denominator in parentheses. So it's gonna look like -20 divided by 2 times, is it 0.708?
3.57.
Like that. So
Wait, if that side is 2.8, then doesn't that mean it's not a square?
it is not a square, you are right.
Oh,
I spoke a little prematurely here because I forgot to look at my diagram. It is still a rectangle where one side is double the other. Thank you. Other questions? Rhea?
So it's 2.8 by
5.6 with a circle of radius 2.8. All right.